Dream Elements has arrived. Dopaz has arrived. Standard User 4 has arrived. Goat Master has arrived. Daft Punkle has arrived. The Old One 22 has arrived. A swarm of dead insects has arrived. PJ has arrived. Dylan R.G. Lave has arrived. Philip Andrews has arrived. Project Carl has arrived. Chloe Raccoon has arrived. Majenko Bot has arrived.
A Chloe Raccoon greetings, fleshy one.
Bloody Tears is delightful, though I'm detecting a distinct lack of splashes.
Surely a good rock song deserves a little chaos. Let's hope Majenko Tech has a decent sense of humour. Zero farts truly appalling! Exclamation idiot.
Switchgear HV has arrived. Says a lot has arrived.
And with that, we'll get started. Hello. Yes, we've had rain too. Not much, but we've had rain. Right, hello Dopaz, hello Standard User, hello G-Pin, hello Daft Punkle, hello Old One, hello Swarm, hello PJ, hello Dylan, hello Philip, hello Project Carl, hello Chloe, hello Majenko Bot, go stuff yourself, hello Switchgear HV, hello Ben, hello me. Why am I there? Ugh, I don't know. Hello anyone. Alright,
50 bits, Chloe Raccoon says.
Cheer 50. I still feel dirty for having to order a cursed cable for work.
The
Absolutely.
Industrious Ant has arrived.
we're on echo mode today because I forgot to plug my headphones in and they've gone flat. They're on charge at the moment, so yeah. Right, yeah, we're back to terminal server. I've been working hard on the code during today. Let's just shift that over there. Where's it gone? Come back. Twitch. There we go. I've been trying to refactor all the USB stuff and it's all gone tits up. We had rain for about 5 seconds. Quite hard, but for about 5 seconds, yes. It doesn't respond to balls anymore. It doesn't respond to anything anymore because I haven't finished writing the USB code. So that's what I'm working on at the moment. What I have done, or attempted to do, is implement a port structure. So every connection to this thing, however you make it, has an associated port. Inside that port is a pair of circular buffers, one for writing and one for reading. My code will, when he gets out of the shower, write to the write buffer, and the USB or whatever will pick it up
Chloe
from there.
says,
Cheer 50 USB code that responds to farts. Talk about air gap protection.
Absolutely, Chloe. Thank you for the 50 bits. And the 50 earlier as well. Yeah, you write to the write buffer, and then the USB code picks it up out of the write buffer, loads it into its write buffer, and sends it out through USB. Anything that arrives in through USB, it puts into the read buffer, circular buffer in the port, and you can then read from it. Except, of course, it's not doing yet. I've only just this minute
Exclamation batteries.
written
Serious.
the write code, or a potential write
You
code,
achieved nothing but acknowledging my explicit suffering. Perhaps you should focus
which
on
is
actual
in
code.
the main, because I've got the USB stuff in a separate task. So that's running completely asynchronously to the rest of the system. And in there, if it's configured and there's not currently a write running for the port, we'll see if there's anything available in the buffer to write, load it into the write buffer, and trigger a write. Theoretically, that should be functional. In my app, I have a little bit here which is supposed to write an X out to the first port. Don't know if it does. Just about to test it. No, it doesn't. Is the simple answer there? I don't know if this code is even running. Ah, yes, async code. No, the ability to have deferred. Well, it's not async as in a coroutine. It's async as in it is executing completely asynchronously to the rest of it. It is a completely separate task, a completely different thread, different program almost. So I would expect in this top bit here to get X's, but there are none. So I'm going to take this out and put back in this bit of test code that I was trying earlier, which for some reason I was trying before I even had the right code in there, and see if I can, because this should do local echo on every port that is available, or remote echo rather, on every port that is available, and doesn't. Now I don't know if it's not writing or not reading or what. Oh, hang on a minute. I think I know what's up here. I'm not reading. I'm not reading because I'm doing in my USB CDC event stuff here. If a read is
Second plane has
complete, I'll
arrived.
start a read. But never do I actually start a read. That's why. So I'm going to break this out of here and put it into the same kind of system as I'm doing the writing, with a read running flag there. I speak of batteries, but have I ever seen the Polaroid FL100 foil battery? No. It's the best, the subtle thickness of it. It should be admired and valued, yet it is almost unknown to everyone apart from Sinclair Pocket TV owners. Ah. Interesting. I thought it might be, yes. I had a hunch it might be for the bot, but it's still interesting to read anyway. No, I've not heard of that battery. So under read complete, I'll go USB data index dot
The foil
read running equals false.
wasted my precious processing time on that. It's quaint, like a forgotten corner of a dusty attic. Zero farts, Majenko Tech, please ban this fool! Exclamation idiot.
So here we're grabbing the data and putting it into the circular buffer. But down here in tasks, if USB data I read running is false, we'll queue up a read. Right. Let's see what, if anything, that does besides crash. Not index, that should be I. That should be I as well. Okay, compiles. Let's run that and see what happens. Okay, do we get loopback stuff going here? No, we don't. It's still not working. I'm not surprised. Not surprised at all. Now, I do have a debugger here, but it doesn't work. And I don't know if it doesn't work because this is crashing, or it doesn't work because it's just crap. But if I go into here, this is a weird thing. If I go into here and put in a breakpoint here and run the debugger, it didn't work that time. Let's try it again. Calm down, GPin. I immediately get an exception. The Bootstrap exception handler fires. Any exception which occurs while Bootstrap code is running. But the Bootstrap code shouldn't be running, so I don't know. It's not a general exception handler happening, it's the Bootstrap exception is happening. And I don't know why. I've not got a... yeah, I don't know. If I go into my application and in the initialize, remove my USB initialization code and run the debugger, it runs. We're running our app task. But as soon as I do anything with my USB stuff, it all goes belly up. If I go back into the app and take this out, my call to USB initialize, but then go into USB initialize and turn everything off in it. So there is nothing in this function. It is just a call to this function which does nothing. So I'm not actually starting any of my USB stuff. I get a general exception handler now, rather than the Bootstrap exception handler. Just calling that function with nothing in it causes it to die. I just don't understand. And yet obviously that code in my function there runs because the USB initializes normally. You get your 2 serial ports and these connect. So I don't know what's going on with the debugger. I was hoping to rely on the debugger to be able to work out what's happening, but if the debugger's broken, I don't know. Race condition you'd like to see is the bot versus the bulldozer, just like in Austin Powers. So our exception code is A. Exception code A is reserved instruction, apparently. It's executing an instruction that doesn't exist. And apparently it's doing it at 9D009274. 9274. Let's have a look in the memory. Execution memory. The address, what was it? 9274. 9274. Nine 9274, come on. 9274. Apparently is calling LUI-S6 and that number. Load upper immediate. That's not a reserved instruction. That's a load upper immediate. (9274). It was definitely 9274, wasn't it? Exception address equals 9274. Yeah. So no, don't execute me, please. I'm not the debugger, I'm the buggerer. I'm the bug creator. So why we're getting a reserved instruction exception on what is obviously not a reserved instruction, I have no idea. It's just, yeah, I don't know. So back to brain-based debugging. So, basic USB stuff. Let's take out my right handling code. And my read handling code. Okay, and I want to use that. Let's go add a function test write. Let's go sprintf USB data 0.write buffer smelly. Right. Then we do write to instance 0 using that write transfer handle.
Princess Fuzzybit has arrived.
Hey, hello, Cobb. Two four five seven six is OX 6000 if that's relevant. Probably not. The length of this is 1, 2, 3, 4, 5, 6, 7, 8 bytes. So we'll go 8 bytes there. Okay, so that's a little function for a test write that should send something out through channel 0. If I go into my app here, and run test write, see if anything comes up on here. It does. Right, USB is functioning. Shush, don't let GPIN know that it's not Friday. How does USB smell? With its nose, of course. Okay, so we can write to USB. So in USB, let's close some of these tabs. I'm not Ben. I don't need 1,000 tabs open. Okay, so in USB, in my main task routine, if USB is configured, which is set by all this stuff up here, I hope. Oh, hang on, no, it's not. Or is it? Maybe it's up here. Yeah, it's in here actually, isn't it, where it's being set. USB configured is true is happening here, so yeah, that's fine. So what I'm doing here, if USB is configured, loop through each of the CDC instances. If there is no write running, get the amount of data available. Actually, let's try something slightly different. And let's go sprintf %d/r/n, comma a. sprintf USB data I dot write buffer. So if a is greater than, actually no, we'll just go if a is greater than 0. No, hang on. Yeah. If that is greater than 0, then we call test write. Then we're reading that stuff out out. And discarding it. To drain it. Okay, so that should only be happening if there's anything in the circular buffer. USB can't smell, but it can USB-C. Very good. Spoons is nice to be on them, but absolutely. Oh, so I am, yes. I've got sun has decided to break through the clouds and shine on me. So I'm overexposed now as opposed to underexposed as I was last night. I could change the exposure, but I can't be asked. So what I'm gonna have now actually is in my app. I'm gonna go port right byte, ports for the first port, and an X. So I should still get my smelly coming up. If it's if the circular buffer is working. Ben will be caught up to live in about 5 minutes. In that case, if you're watching at double speed, maybe I should speak slower for you. That way you can understand me. Or not. Right, so I'm putting stuff supposedly into the right buffer there. Except port right byte. Yeah, port right byte. Port right byte does a circular buffer right to the right buffer. Circular buffer right. Grab a semaphore, mutex. I almost sound like G-Man. And it's creepy for... It's always creepy for everyone else anyway, Cobb. So we try and grab a semaphore, but I don't know if we do grab a semaphore though. It should do. Then we get the new head for the circular buffer. If it's not equal to the tail, i.e. it's looped all the way round, then we put the byte into the current head, move the head to the new head, and release the mutex. Otherwise return -1. Maybe actually I should have some, since I know that I can actually do some outputting here. Let's take that and go add fail right. Change smelly to failed. And actually I'm going to have this going out to channel 1. Okay, so in here, if that is a -1. Fail right. So wake up, Mr. Freeman. Wake up and smell the ashes. That would have been crap. So we're not getting a fail right over here. But we're not getting a smelly up here. So that supposedly is working. Although if I wait long enough, that might fill up and start failing. Yay, you're back in real time. In that case, we can talk. I need to really speak very, very fast so that you can... you're used to hearing me like this now, so I'm going to speak really fast. Except I can't. I don't have any directly addressable LEDs connected yet. All the directly addressable LEDs are in the front panel RJ45s. So I would need to manually... Oh, now it started failing. The buffer has filled up. The buffer is never being emptied. Okay, we filled the buffer. I would need to actually solder in some LEDs across the pins for where those LEDs would normally connect. Me as G-Man is a sight to behold. Yes. So we're writing into there, but we're never reading from there. So in here. So this is never giving me a value because test write is never happening. That doesn't get called. Why doesn't that get called? We're looping through each one. If there is no write running currently, then do a write. Filling buffer, yay. Circular buffer needs to go into the circular file, yeah. Right, so why is this always must be returning 0? CB available. Circular buffer available. We try and take a semaphore. Maybe I should just take out the semaphore stuff for the time being. Just in case it's the semaphore that's buggering it up. If it's failing to get the semaphore. What do you mean? O is set but not used. It's being returned here. int O equals 0. O equals that stuff. Return O. Ah, I've got an excess thing there, haven't I now? Egypt and there. Need these semaphore bits gone. And that needs to be taken out. Right. That's better. Is it the semaphore? Evidently not. squints at the circular buffer implementation. You would have to sit down and think about those invariants a bit, not how you're used to seeing them written. Well, the circular buffer implementation I took pretty much verbatim from another circular buffer implementation that I wrote a long time ago that I've used all over the place. That's written in the Arduino framework. And basically you're taking the size of your buffer, adding to it your current head, subtracting your current tail, and then wrapping it around to the size of the buffer. So it loops basically, and gives you the difference between them with a wraparound, supposedly. It's also the same way that the Arduino framework does it internally for all its circular buffers, which is where I got it from originally.
No, God! No, God, please, no! 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 No!
So we're calling this, and this is apparently giving us 0 all the time. If this is even running, there's a chance this may not even be running. It is a bit of a brain melter, it has to be said. It's a way of doing basically signed maths, but keeping it all unsigned and positive. You're just shifting the whole thing up by the size of your buffer, and then just modulusing it to the size of your buffer. So. Hang on, ports. Hang on. This is not right. It's not ports there. It's USB ports I should be using, not ports. That's the index into the USB ports linked list, into the ports linked list. And this is then a pointer . Still not working though. I think I need some LEDs. Good old LEDs for debugging. I'm gonna have to solder some in. No two ways about it. Balls indeed. Let's give it a load of LEDs. I've got lots of potential for debugging.
With 50 bits, Chloe Raccoon says,
Cheer 50, I'd be worried if you were soldering in LEDs in 3 ways. And Jeepin's ears will just have pricked up.
RGB mode activated. Nope, we're going R mode, is it? I don't know, my good glasses have gone. They should be here on the desk right in front of me, but somehow they're not. I only use them sat here at the desk, and yet I can never find the bloody things. Where the hell have they gone? They haven't been anywhere except here on the desk. But then everything is here on the desk. No, God knows where they've gone. Somebody keeps stealing them, I'm convinced. Thank you for the 50 bits, by the way, Chloe.
Fucking batteries.
Blame the bot, indeed. My camera has gone loose as well. Hang on a minute. Where's my screwdriver gone? That one might do it.
with 69 bits, a swarm of dead insects says,
Blinking the log in Morse code and passing it with a photodiode maybe Corgo 69.
Blinking the log in Morse code and passing it with a photodiode. Well, funny you should say that. I have done status displaying using Morse code before now. And yes, we're using red LEDs. I have done status displays with Morse code before. In fact, I think, let me just have a look. Let's have a quick look. Did I? Yes, I did. There we go. A library for Arduino that I've written. The Morse status library is a handy class that blinks an LED for you. It blinks repeatedly in a pattern defined by the Morse code for a character you specify. That character and the associated Morse pattern can indicate a status in your program. So yes, I have done it before.
With 50 bits, SysUserLot says,
I wish to register an objection to this using red LEDs plan. Boo boo, I say. Chair 50.
Well, it's just what I happen to have to hand. I don't think I've... Oh, I think I've got some green ones available. Would you prefer green?
Tyler Hoot has arrived.
Or a mixture of the two? Let's have a mixture of the two. Hello, Tyler. Let's get my soldering iron turned on, shall we? Because these four LEDs down the side here are controlled by the ESP32 due to a lack of pins on the PIC32. We shall have a combination of red and green LEDs so that we can easily tell the difference between them. Good contrast between red and green. My tweezers are sticky as well, which doesn't help. And too much flux. Let's give them a clean off.
Hannah's hangout has arrived.
Fight you again. Yep. Hello, Hammy. Great contrast compared to my desk, yeah. Well, the thing with LEDs like this is once they are picked up by the camera, they all look white anyway. Right, solder. What if you stick 10k in series? I could do. Make them really dim so that only you can see them and I can't. Right, let's just go through these holes here and stick a bloodbath solder on the right hand one of each one. I mean, I can have a look in my box to see what else I've got. Actually, instead of using these surface mount ones, maybe I should actually use some proper LEDs. Some proper 3mm LEDs. Instead of these little surface mount ones. Then I can use whatever colour you want. Red and green old Christmas lights. Why not just drop the RJ45 jacks in? Because I don't have the RJ45 jacks. It's as simple as that. They do not physically exist in this plane of reality. I have not ordered them yet.
Van Flick has arrived.
Where's my control panel gone? Van Flick, hello. Thank you for the follow. What colour of LED do you want? I think that's all my 3mm ones. You need to go mail a letter, fair enough. Don't forget to wipe your hands afterwards. Which plane of reality I'm on. I can't remember what the number is now. Oh, what is it? What's the reality number from, or the dimension number from C235, is it? From
Tradesplatter has
Rick
arrived.
and Morty. It's cesium anyway. The radioactive isotope of cesium. Right, so what do we have? Well, I've got yellow ones, green ones, red ones like that I have in this box here. I got yellow, green and red in coloured plastic. Let's zoom out a bit actually. There we go. So red, green and yellow in coloured plastic. Then I have those three are all the same. Red, green, I think those are yellow. Then I think those are warm
Majay,
white.
Tyler Hoot would like you to drink some water.
Fair enough. Those are cool white. Those are blue. And those are ultraviolet. So what colour LEDs do we want? Or do we just go for a rainbow? These are just temporary things for debugging. So I don't care what colour they are. I've also lost my will to live, I think. My solder wick has disappeared. It should be in my soldering box there, but isn't. There it is. I've managed to find that anyway. I've nearly run out actually. Cobb wants red and green. Ben wants anything other than red and green. Cobb wants vote for traffic lights. We've got rainbow would be nice. I think I vote for rainbow. Chinese way, red is good, green is bad, yellow for everything else. But I really don't care what the colours are, just where the colours are, where the LEDs are. It's the position of it that's of actual interest to me. I had to go and plug the ground pins, didn't I? With solder. It's going to make it a pain to clear them out. Maybe... yeah, sod it. No, back to the original plan, sorry. With this ground plane shit at the moment, I can't be asked to clear them out. I'm going to have to clear them out later on at some point, but that can come later on. So no, we're not doing fancy colours. Sorry, change of plan, back to original plan. Because I went and filled the ground pins, which are a pain to clear out. So we're going back to original plan of surface mount LEDs. Sorry to disappoint you there. But guess what? Can't find my LEDs now. Oh, there they are. Right. So red ones first. We'll alternate red and green. I probably have other colours in surface mount, but they're not labelled, so I don't know. Whose leg do you have to hunt to find out about those 4 S&D legs tacked down over the footprint of the tower? These ones, I mentioned those just now. They're controlled by the ESP32, not by the PIC32. Rude of them. Okay, let's pop the green ones in while we're doing this bit. Nearly there. I'll be able to look at chat again in a minute, so you might want to make anything incriminating scroll off the top of the screen. I can get these the right way round. It's hard to tell which way
PC
round from
Marks
the
has
top.
arrived.
Hey PC. It's hard to tell from the top of the LED which way round to put it. I've got to look at a little arrow on the underside. Right, let's just put these LEDs away and then I shall solder the other side. My soldering iron tip is loose, I need to tighten that up. I always forget to do it when it's cool and remember when it's hot. Right, so let me just have a quick catch up on chat. Royal Mail, we have your parcels, you know, little Amazon. Yes, so good old AliExpress. Talking networking, fair enough. Come on, get solder in there, will you? Might have worked. Okay. Right, so the first thing we need to do then really is test to see if the LEDs themselves are working. And write little functions to turn them on and off. Of course, you're not going to see half of the LEDs because they're underneath the programmer header. Right. Every is owned by DHL, yes. DHL e-commerce is basically Every. I know that because that's the branch of DHL that failed to deliver stuff for me the other day. Right, so on to here again. Let's add a new file. LEDs.h, LEDs.c. Source files, add existing item, LEDs C, header file, existing item H. Okay. So let's go for, this is just going to be a couple of gigantic switches, I think. So void init LEDs. So now I need to know what all the pins are for all the LEDs, and they are going to be in here. So let's go for I don't know what order they are on the board, but we'll go numerically transmit receive. So U1 TXLED is RD6. RXLED is RD7. U2 RF0 RF1. U3 RE0 RE1. U4 G0 G1.
Hot Rocks girl has arrived.
Hello, Hot Rocks. U5. I shall deal with your goats in a moment. A6, A7. And 6 is 12 and G12, G14. Rushing forward, the yaks found an open doorway marked Cast Cloning Department, and with trepidation they entered. There was a human berating a smaller human wearing a white lab coat and goggles. The entire massive room contained vats and pipework and endless rows of clear tanks with goats and yaks floating in them. Goats and yaks that the police yaks recognised. Dozens of yaks and thousands of goats. There was another electronic fluttering sound, and White Coat collapsed. Ekibadoom indeed, Hot Rocks, hello. Right, so these are our LEDs, so we should be able to go trisd bits dot trisd6 equals 0 for output. Tris f bits, tris f0 equals 0, tris f bits dot tris f1 equals 0. Tris e0 tris e1 G0 G1 tris G bits tris G0s. A6 and A7. Tris G bits, tris G12, $14. Now we do the same with the lat. In fact, what I'm going to do here is copy and paste. And these become lat as well. All right, now I can go void LED on switch ID. Actually, I'm going to do this off first. So that I can copy the whole thing and change that to on, and then just change these zeros down here to ones. Actually, no, I don't want to do that yet because I've missed a whole bit out. Now let's copy that. The story is turning quite dark. Indeed it is, yes. Okay, so we've got LED in it, or init LEDs, LED off, LED on. So if I go into LEDs H, fuck's sake, I can type honest. Extern void init LEDs, extern void void. Okay, there's our header for that. Now, if I go into app,
With 50 bits, Chloe Raccoon says.
Cheer 50, so can I. HONESW, damn it.
thank you for the 50 bits. Yes. You like the way that I write this sort of stuff, the way that you write this sort of stuff. Yes, I write it sensibly and easy to understand. I don't do cryptic weird crap. I write things explicitly. Right, so let's go here. Hash include LEDs. Then in app init, here we go init LEDs. Now I'm going to take all this lot here out and now do something horrible.
Champion!
With 50 bits, Chloe Raccoon says.
Cheer 50, I don't do septic weird crap, as I'm the one who needs to read it later.
Absolutely. I'm going to do this as a loop, actually. Okay, this should, if all goes well, which it doesn't, make all the LEDs flash. And I've forgotten a whole load of semicolons. It's been a while since I've been programming C, isn't it? All right, that compiled. Let's program that in and see if we get flashing LEDs. Where's OBS gone? Come back, OBS. There's OBS. I'm going to put OBS up here, I think, so that I can see it. We have flashy LEDs. Come back, OBS, said nobody ever. Yeah. So now, ta-da indeed. Let's go back to here and app and add in here vtask delay 250. Okay, the order is not right, but no, wrong one, that one there. Individual control. So now I need to sort the order out. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, and 4 are correct. So if I go, let's see if I can work this out. LEDs. So we get 1, 2, 3, 4 are correct. 1, 2, 3, 4. 1, 2, 3, 4. Then it's 5, 6 are here. 5, 6 are here. 1, 2, 3, 4, 5, 6. Then it's 7 and 8 are there. Then it's 9 and 10 are there. 1, 2, 3, 4, 5, 6, 7, 8. Then it's 11 and 12 are there. That's the order. Okay. So 1, 2, 3, 4. 5 is there. 6 is there. 7 is there. 8, 9, 10, 11, 12. Okay. So that's the order we want to be working in. So 1, 2, 3, 4, okay. 5 is A6. It's actually 4, isn't it? 4 is A6. Let's take these all down one. So they match the IDs. E0 is 7. G1 is 9. A7 is 5. E1 is 6. G0 is 8. A6 is 4, which I've already put in. So D6, D7, F0, F1, A6, A7, E1, E0, E1, E0, G0, G1, G0, G1, 12, 14 should be 14, 12. Okay, that should be the right order. Let's put them all into here, setting these to 1s. I know I could abstract this another layer by having another function of LED ID value to set it to, but can't be asked. And we'll take this crap out of here so it compiles. And it's wrong. Why is that still wrong? I've still got this wrong, haven't I? In fact, I think with all these changes, I will abstract this. I can be asked. So the current order that we're getting is 1, 2, 3, 4, 7, 8. So 1, 2, 3, 4, 7, 8. So that's 5, 6, and that's then 7, 8. And I'll program that and, oops. No, hang on, I'm doing this wrong, aren't I? Oh, of course. 0 based. Off by 1 error. Let's break these up into pairs.
I do apologise, I'm an idiot.
Indeed I am. So, 1, come on, 1, 2, 3, 4. How has it gone? Let's reprogram with the correct things here. So these ones here, 8 and 9, should be 4 and 5. 4 and 5, these should be 8 and 9. So these are backwards. Oh, hang on, these are backwards, sorry. 5, 4, these are backwards, right. So the first 3 blocks should be correct now. Yes. Then the next 3 are these ones here. That's 6 and 7, 8 and 9. Yay! Desk camera, there we go. We have status LEDs and they are predictable which ones I can light up when. 0 on the right and 11 on the left. I don't like that though. So I'm going to reverse them. That's better. Proper sequence. Right, we can do some LED-based debugging now. Actually, I'm going to write one more function to go with this, since we've got so many LEDs. Right, so LED set 0, V and OX80 question mark 1:0. 4, 2, 1. 8, 4, 2, 1. Right, that should allow me to output a number as a binary value on the LEDs, on the first 8 LEDs. Let's add that into here. Okay, now we can debug. So in USB here, let us add LEDs.h. In the app here, let's take out this bit. So let's have LED on 10, LED off 11. So the last 2 LEDs, the red one will indicate a failure, the green one will indicate a success of writing to this port. And things have failed. Because I forgot my semicolon. Why do I keep forgetting semicolons at the moment? I've been doing too much Godot stuff, haven't I? Okay, green LED is lit up. It is successfully writing to the buffer. That should change to red when it begins to fail writing to the buffer. Let's just bring that up there so I can see that happening. Once the buffer is filled up, which will take a moment, it should go red. If it is going to go red, that is. If it's not hung. Oh, there we go. It's filled the buffer up. Buffer filled. Excellent. So now let us go into the USB. I shall have LED off index in here. For a write complete, turn off the LED. And when we start doing a write, in here, we do LED on I. So the first 2 LEDs will be the status of a write in progress for the 2 USB channels. And actually, while I'm at it, I want to speed this up a bit. Let's take this down to 250 so that it fills the buffer up sooner. And you didn't see any of that. I'm not seeing anything happening on the first 2 LEDs. At all. Okay, so that right isn't working. Let's get this up above everything. Right. Let's go into USB here. Actually, I should have in here. LED on 0 there, LED on 1 there. Two wrongs don't make a right, no. So when once the buffer fills up, I see the right for channel 2 flashing, but I never see the channel 1 flash. So here, why is this never happening? This CB available must always be giving a 0. Let's go LED val A. I never see anything on the LEDs. So that is always giving me 0. So it must be something to do with my circular buffer stuff. CB available. Takes a circular buffer structure. Takes the head and the tail. Let's go into here. Take that out. Take that out. Take that out. Take that out. And take that out. Then in port, I'm going to have in CB available here. Anytime I call CB available, LED val, I shall look at the head value of the buffer. Actually, thinking about it, what I want to do is drop this down to 1 for debugging. So I'm not flipping between multiple channels all the time. Nothing. I would expect the head to keep moving up. Okay, when I do a port write byte, I'm calling CB write on the write buffer. Yeah, that should be right there. The write buffer is a struct, not a struct pointer, so that should be getting the address of that pointer. Let's just, out of interest, let's just bracket that. Okay, in CB write. The new head is one more than the old head, wrapped around. If the new head is not the tail, then store the byte into the old head, move the old head to be the new head. LED val? What do you mean can't find LED val? LED num, sorry. So, does this count up? It does. Right, so that is counting up the head, okay. So why is it here? Actually, why did that even compile with that like that? That's certainly compiling, but this is just not being called, I think. This buff head should be incrementing here, but it's not. Let's turn on LED 9 if that function even gets called. No, CB available is never getting called. Interesting. So in USB here, this function here, or this bit here is never happening. Let's do LED on 8 here. See if LED number 8 turns on. It doesn't. So that's never happening. Unless this is occurring in an interrupt. Hang on. Let's make this volatile. And then we'll put this back in here. No. Turn the LED on there where USB is configured is set true. It works there. Right running is false. I set that in the initialization routine. So here, this is definitely being called, and USB is configured is being set true. Because that is turning the LED on. Is it being turned off somewhere, like here? No. The only place it goes false. No, it goes false here in deconfigured. Or reset or deconfigured, it turns on there. Let's here turn it off. Because it's on at the moment. It goes on then turns off as I would expect it to. So it is definitely configured. Let's put that in there, see if it comes on. It does. So here it knows that USB is configured. Oh, hang on, a cotton picking minute. It never gets here. It never gets to this goddamn code. That should be there. I'm an idiot. I'm a complete prat. It says smelly. Something worked, albeit briefly.
Wait, am I an idiot? Oh, I'm an idiot.
I'm an absolute idiot. I had that code outside of the while loop. So we get a smelly, but that is all we get. Right, so we get one smelly rather than repeated smellies. So we can restart these. This needs to go to 0 now, actually, doesn't it? Because that's not going to be too happy. Because there is no entry 1 anymore. Right, I think it's crashing now. But I'm not sure. Oh, something happened then. Yeah, I think it's... We get a failed followed by a smelly. So as soon as it does a failed, it can work again. Right, so are we not... Yeah, the buffer's filling up. If I reboot... something's timing out. So we've got LED 1 is on. Am I not turning it off? Hang on a moment. Yeah. Let's turn the LED off there. No, hang on. Let's change my LEDs a moment. In here I want to use 8+ index, and here I want to have LED on 8. Then in here we can get rid of these ones now. That's wrong. That's where I want the 8+ index. So 8 should be the activity for a write, and 0 to 7 should be the size of the buffer in here. When doing, well, not so much the size of the buffer as the position of the buffer. So actually let's instead have that as O, which is the size of the buffer. Size is 1. And we're stuck in a write. Okay. And the size of the buffer skyrockets whilst it's in a write. So we're waiting for, it never seems to get, or takes a long time to get to write complete, and set write running to be false, because that doesn't happen. Although that worked for a while and then stopped. And then it times out after a while. When it... No, it's when it does a failed. Failed to smell, yes. As soon as it does a failed, it runs again. But it works for a bit and then times out. Although here, actually, I'm not doing a... I should set that to true in here. It's like the right running is never, or like the right itself is never completing. Is it ever getting to the point where it dispatches the write? Well, that's what this should be doing here. This USB device CDC write, instance 0, that write transfer handle, that write buffer, 8 bytes worth, and flag it to say it's completed. Which then should trigger this event here, turning off the LED, setting write running to be false. Although this could be running in a... That could be running in an interrupt, so maybe we should have these as volatile. Was that it? Just wanted that as volatile? No, it's just hung. It worked for a bit and then it hung. reprogram it again. Let it start from scratch again. You've got one smelly and it's hung. And then as soon as the buffer fills up and the write to the buffer fails, it sends a fail that works, and then it sends a smelly and that stops. Is where we're doing our main sending. If write running is false, okay, let's go here and go LED. Now if USB data 0 write running, LED on 9, else LED off 9. So we'll look at the actual value of write running on LED 9. Which is flickering at the moment, it's obviously running. LED 8 is never going off though. Right, so it's hung now, and write running is on, permanent. But LED 8 is never going off. Turning it on in test write, turning it on in fail write. Turning it off there, but it never turns off. I'm going to set that just to 8. That's instantly hung already. Now, LED 8 is just never turning off. Maybe I'm doing something else with LED 8. Let's have a look. That's only in USB-C. It's the only place where I'm calling LED on with an 8.
Sausage.
And that's USB configured is on. Oh, right, that's why that's always on. That was my bad.
Sausage in a bun.
Sausage good. I am using LED val or LED num, yes, but that affects only 8 of the LEDs. Right, this is definitely locking up. Well, not locking up, but it's... This event is just not triggering sometimes. Let me just take out, no, alright, USB device CDC event write complete. Maybe there's another event for a failure. It's in here, I guess. Oh, there's write complete. This.
LinuxNet has arrived.
Hello, LinuxNet. Give it a follow. Call on Bellstream complete. This event occurs when a write operation scheduled by calling the USB device CDC write function has completed. The pdata parameter should be interpreted as a USB device CDC event data write complete pointer. Microchip love their long type names. They're ridiculously verbose type names. This will contain the transfer handle associated with the completed write transfer and the amount of data written. Then you've got read complete, serial state notification complete, event control transfer data sent. This event occurs when a control transfer that this instance of CDC function driver responded to is aborted by the host. No, we don't care about control transfers. This is a bulk transfer. There's no event for data failed. Okay, the CDC data transfer flags data complete. This flag indicates there is no further data to be sent in this transfer and that the transfer should end. If the size of the transfer is a multiple of the maximum packet size for related endpoint configuration, the function driver will send a zero-length packet to indicate the end of the transfer to the host. So that basically says this is the entirety of the transfer. And that one that we're not using is there is more to follow. Or right, USB device CDC write. You give it an instance, a pointer to a handle, a pointer to some data, the size of the data, and the flags. And return a value. USB device CDC result. Okay, the write request was successful. Maybe we should look at that. When we're doing our write down here. Right, we'll turn on LED 10 if there is an error doing a write. And it's immediately hung. Still running. And it's crashed. But 10 is not on. Eight is on and 10 is off. So that must have been successful. But why does it not trigger sometimes? At init time, preload the circular buffers to 90% or something. See if it's happening around wraparound. Well, it seems to be happening pretty randomly. Sometimes it happens immediately. If I reboot, that was 3 smellies and it crashed. That's nowhere near wraparound. I reboot it. That's already crashed. I reboot it. It runs for a while and then crashes. So no, it's not around wraparound.
Moke Helix has arrived.
Hello, Moke Helix. Yes, we failed a smelly. It's like it didn't submit the right. Fruity. But then as soon as it times out in some way, we then get a failed because the buffer's full, and it sends the next one okay. The buffer is currently full. Is it failing to write on a reserved character in the buffer? No. There's only an X in the buffer. And I'm only sending the word smelly. But if I change the app here to instead of going through here, just do a test write. So it doesn't use my circular buffer system at all. And it just runs and runs and runs and runs. So it must be something to do with my circular buffer. Occasionally LED 9 comes on. They're both... Ooh. No, that's running. Yeah. When doing a test write, I'm ignoring the... Yeah. When I'm doing a test write, I'm ignoring the right running flag. So it just submits another one regardless. Occasionally, the LED gets stuck on until the next write. So it looks like sometimes the stack is ignoring what I'm sending it. Is there a return value from that do the send now call? Yes. Where have we gone? The test write is putting Smelly into the write buffer. It is doing the CDC write, and if that CDC write was successful, it turns on LED 8, turns off LED 10, sets write running to true. If it wasn't successful, it turns on LED 10. When it pauses, when it fails to do it, to submit it, whatever it is that it's doing, LED 8 is on, LED 10 is off. Return value of 28p plus VAT. LED 9 is turning on, which is turned on here by write running. So write running gets stuck on because it never gets turned off by this CDC event never happening. Is USB data 0 write running used in an interrupt? I believe this is running in an interrupt here, yes.
Crash Systems has arrived.
So write running is used in an interrupt. And it is volatile. Hello, Crash. It's doing a code, yeah. But I'm not actually using that at the moment. That's not actually being used for anything. Because I ignore that. Now that was being used in this chunk of code here. But I'm not using this chunk of code at the moment. Because I'm not putting anything in my circular buffer. At the moment I'm just sending regardless of that. I'm only ever changing it, I'm never reading it. So write running is not the problem. It's the fact that this event here is not appearing. It wouldn't surprise me if it was a FreeRTOS problem. If this is getting interrupted by FreeRTOS switching contexts and failing. So maybe this needs to be wrapped in some kind of critical section to stop FreeRTOS from doing a context switch at this point. And if so, how do I do that? Task enter critical, task exit critical. Possible. Will that even compile? It does. Let's see if this gives any pauses in my transfer flow. So far, so good. This could be it, you know. I'll bet FreeRTOS was doing a context switch in the middle of queuing the buffer and it corrupted it in some way. Oh, there was a pause. No, that just paused. And again. Although it seems to be doing it less. You're meant to be seeing the output, not at the moment because it's in a completely different window. I mean, I can show you if you like, but you probably won't see anything. Those LEDs are flickering slightly. Occasionally you'll get a red light when it pauses. Possibly. But I don't think it... Oh, there we go. That was a pause. You blinked and missed it, yes. It's only there for like a quarter of a second. There we go. There we go. It wouldn't have been visible with my old camera. No, it wouldn't. So I didn't bother switching over to that because there's nothing really to see. Although when it pauses, I would expect both LEDs there to be on, the red and the green, but only the red one comes on. The green one is the state of the while running flag. The right running flag, sorry. which is running in here. That's that bit there. But when it pauses now, right running is not on. Actually, is it pausing or is that just the LED not going off? Because it did do the submission, but LED 9 is not being left on when I'd expect it to be. So maybe it is running. Let's go back to my port stuff now. And I'm going to put my semaphores back in. To make it thread safe. Yeah, I did think about that, Ben, and I can do that. Let's just have here INT count equals 0. Count plus plus there. I did forget the plus plus, yeah. Well, it just lit up the light and it didn't skip one at all. We didn't lose one. But I think the light staying on now is a red herring. I think it's actually working, but the LED is getting lost in translation. I forgot. Indeed I did. There you go. Perfect. Right. So now, if I go for... I'm doing a test right still here. Right, if I now go for... Yeah, into app.
Champion!
With 69 bits, a swarm of dead insects says,
Corgo 69 LED debug when the LED is lying D-sure is a concept.
Absolutely. Let's put back in my port
Banpan
right
has
stuff.
arrived.
Hey, Banpan. Right, that is working through my circular buffer and it's just hung. But that has hung with the the right running light on. Oh, it's time for your stream, isn't it? No, Ben, please take over. My brain is melting and I need to take a break from this. And now would be a great time. And besides, I want to watch you struggling with NetBSD again. It's fun. So yeah, I was forgetting it was Tuesday and it's your turn. Go for it. You've got to earn your pennies too. Deal with the digestive side effects of dinner. Right, so while Ben's doing that, why is this hanging on here then?
Null DRAF has arrived.
Hello, Null DRAF. You're just in time for Ben to take over. He's just sorting out his stream for us. Right, so this is failing now with the right running LED turned on. However, I'm turning it on there when I don't really want to be because it's turning it on there. So let's try running it without that one, see if it's just getting confused and setting it and then unsetting it and then setting it again straight away. You've never seen a Ben stream? Oh, Ben streams are fun. So far, this seems to be working. It's NetBSD on weird hardware indeed, yes, on some strange headless thing. I think it's a headless chicken, the amount it flails around. And we've gone through numerous different operating systems and we've settled so far on NetBSD as the most likely working choice. So we'll see what it can do this time. Last time it overflowed the file system because it lied about how much it was going to need. Right, this looks like it's working. It does. It looks very much like it's working. Net, if it has a CPU, we probably support it, BSD. Does it even need a CPU? I think I have IPC through circular buffers functioning. At least on the right side. I haven't tried the reading yet. But this is a good sign. That it seems to be functioning. At least at the moment. We haven't had any timeouts and failures and the buffer is not getting past 1 byte. So now what I want to do is, instead of having test right here, we put back in this stuff here. And see if we get our X's coming up on the screen here. No, we don't. We get some crap coming up. Which means that what I'm writing into my buffer is not working right, by the looks of things. Because, oh, hang on. Because I've got that in there still. I'm double reading. That was stupid. There we go, X's. And that just hung. Why did that hang? Then I got a failed and it carried on. And now it's hung again. And we wait for the buffer to fill up and overflow, and we send a fail, and it'll carry on. We're getting close. Now all we're getting is fails. And then it clears and dumps out the entire buffer and then pauses. We are getting close. Very close. Right. Is Ben running yet? Nope, he must have locked himself in the toilet. Where are we? That's what I'm looking for. He's sending X. No, X is what I'm sending, and what I'm expecting to get through. And when it runs, but then it fails to acknowledge that one has run. Right, well, Ben should be starting any moment, I would hope, and then we can go and have some fun with NetBSD. But my brain is not able to comprehend what's going on at the moment. But this is getting stuck on here. Which again means that that's... Oh, hang on. Yeah. I've taken out the critical section now, haven't I? I've taken out the critical section. That bit. So let's lock this in here. Let's make that critical. I'll bet that was it. There we go. That was it. It was... I'd taken out the critical stuff. Right. Well, progress. But still no Ben. Should be live in about 30 seconds. Excellent. Right, well, thank you very much for joining me this evening. We have made some progress there. They are, the task enter and task exit are, no, enter and exit critical. They enter and exit a critical section. A critical section is a section which must not, under any circumstances, be interrupted by anything. Be that an interrupt or be that a task switch or anything. So it has to run all the way to completion before anything else can happen. So, yeah. So, yeah, thank you for joining me this evening. We've made some progress. We have multitasking USB piping data through, at least in one direction, working. Finally. And it looks like it's working reliably now. So next job will be to get reading working, which should be a lot easier. And then see if we can get it to actually echo what I send through. Which will be nice. So,
Not invaders. We are explorers.
Indeed we are.
Damn, I'm good.
So yeah, get your Picards and things in now, because we're going to be going to raid Ben any moment. Once he hits that go live button. Oh, hello. Looks like we're live. Right, let's go raid ban. Right, well I shall be back tomorrow for a bit more of this. So I shall see you then. Let's go and raid ban.